Hey yo, what's up? It's your boy JOSHABRAHAM. We're back, live and strong. I don't want to get up. Properties of elements. Anions are generally bigger than neutral. Yeah. This did this. Ionization energy. I think we should stop with chemical bond. The two atoms or ions are held together by a chemical bond. Chemical bonds are regarded as strong interactions between atoms. In establishing a bond, this is called valence electrons. In establishing a bond, the so-called valence electron, the electrons at the outermost layer, plays an important role. Valence electrons are found in the outer shell in often not fully occupied orbitals. A graphic representation of molecules with respect to their valence electrons is given by the so. Get the fuck out of here, bro. It's given by the so-called Lewis structure formula. Graphic representation of the molecules with respect to their valence electrons is given by Lewis structure. Okay. One reason why a chemical bond is established lies in the so-called octet rule. In a strict sense, applies to the elements of the second period plus halogenides. Thereby, atoms tend to lose gain or share electrons till they are surrounded by 8 valence electrons. Series at a time for 30 minutes. Series at a time for 30 minutes. Why do you listen? One reason why a chemical bond is established lies in the so-called octet rule. Let me get my Bible. The Bible! It's been a while since I saw this guy. It's what? It's off? Where's the cable? Not this one. Oh my god. Oh my god. Some water. Let me get some water. Thereby, atoms tend to lose or gain electrons till they are surrounded by. So they try to obtain the electron configuration of noble gases with fully occupied orbitals in the outer shell. There are three types of strong chemical bonds: the ionic bond, mostly resulting from interaction of metals with nonmetals. That's the ionic bond, okay. The bonds based on attraction of ions with opposite charges. Covalent bond, electrons are shared between these two atoms, between two atoms. Metallic bond, electrons are shared between many atoms, okay. Interaction of metals and non ionic bond, interaction of metals and nonmetals. Covalent bond, electrons are shared between two atoms. Metallic bond, electrons are shared between multiple set of atoms. Many atoms, yeah, multiple, many. Electronegativity according to Pauling. Electronegativity value have no units. Pauling's electronegativity of elements. Electronegativity describes the tendency of an atom to attract a pair of electrons towards itself. What? Ionic bonds are formed between elements with low ionization energy, mostly metals, located in the left side of the periodic table. For the formation of ionic bond, the difference in electronegativity between the bonding partners should exceed the value of 2. Pauline's electronegativity values were measured directly. They were derived from the experimental data of the bond energies. Here's the process broken down. Pauling's noticed that the bond energy of the heteronuclear bond A to B is often higher than the average of the bond energy of the homonuclear bonds. Higher, okay. So mathematically, D is the bond dissociation energy. This extra bond energy is attributed to the ionic character, which reflects the electronegativity difference between the atoms. Pauling's equation. This he defined the electronegativity differences delta x as delta x equals root of. Here the units are electron volts or sometimes kilocalories per mole. Then he set fluorine as a reference most electronegative and scale the other elements accordingly. So if fluorine is the most electronegative, that means fluorine has the highest tendency to pull in atoms. So when it's said fluorine has the most electronegativity, then that means according to the definition, F has the highest tendency to pull in electrons from its neighboring what? Neighboring what? Atom. Purple party goal. This is basically me using ChatGPT every day. I mean, it's just how it is. Everybody uses ChatGPT nowadays. It's just, and I appreciate for checking out the stream. Purple party girl. Exactly. According to the Pauling's definition, electronegativity reflects an atom's ability to attract shared electrons in the covalent bond. Highest electronegativity. So ionic bonds are formed between elements with low ionization energy. And Pauling used bond dissociation energy. What was this exactly? Ionic bonds are formed between elements with low ionization energies and elements with higher affinity. Low ionization energy. What does that mean? Ionization energy is the energy required to eject an electron, right? Yeah. Located on the left side of the periodic table. Left to right, atomic radius decreases. Okay. Which means ionization energy increases. Pauling's electronegativity equation refers to the bond dissociation energy of the chemical bond. Bond dissociation energy is the energy required to break a particular bond in a molecule into neutral atoms in the gas phase. It's usually expressed in kilojoules per mole. For example, HH bond dissociation energy is 436 kilojoules. That's the energy needed to split. Okay. Okay. Okay, now ionic bonds are formed between elements with high, low. Stupid. So here, the low ionization. I could use my keyboard. ionization energy means it's easier means the energy required to eject an atom, an electron, from the atom is low. The bond occurs when and a bond occurs when two elements of low and high IE forms. Exactly. Low ionization energy atom can easily lose an electron, usually a metal. Metal. Why metal? Why metal? Why metal? Okay, okay. High electron affinity. The electron readily gains an electron, usually a non-metal. When these two atoms interact, the metal donates electron to non-metal. Yeah. Electrostatic attraction between these oppositely charged ions is the ionic bond. So it's an electrostatic attraction. Now, what is an electrostatic attraction? I don't know. Could you explain on the electrostatic interaction? Because I'm not remembering what it is. What? It's where? Two live streams? I don't get it. How is two live streams going on? Okay. It was just a glitch. Edit. Man. OBS, stop playing. Stop playing, OBS. Stop doing that shit. Okay. Electrostatic attraction is just the force that pulls opposite charges towards each other. Okay, opposite charges, okay. In the context of ionic bonds, the metal loses an electron. Losing electron, what charge is it? Negative. Positive. Yeah. Okay, come on. Losing an electron means there's a need for electron, right? Yeah, the atom becomes smaller. The atom gets smaller, which means it non-metal gains that electron, becomes negatively charged ion. Since opposite charges attract, the cation and anion are held together by electrostatic force. So, could you explain on why the one losing electron is the positive charged cation, and the one gained the electron is the negative charged anion. Get the fuck out of here, bro. For the formation of ionic bond, the difference in electronegativity between the bonding partners should exceed the value of 2. An atom is neutral when it has same number of protons and electrons. If it loses an electron, okay, if it lost electron, oh, it had more protons, so net charge is positive. Ah, that makes sense. That does make sense. Losing an electron, the proton has more power in a sense, and proton is a positively charged. So if I understand this correctly, it's easier for cations to bond with others compared to anions. Not exactly. Easier is not the term, but cations and anions naturally attract each other because of the opposite charges. That's the basis of ionic bonding. Ha 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 ha. Cation is attracted to the anion. Electrostatic force, bond strength depends on the magnitude of the charges and distance between them. Coulomb's law. So the cations bond more easily. It's opposite of the charge. Okay. Protons, so it's easier to. So when ionic bonds form, does the non-metal slash the anion counterpart pull in the electron from the cation, which results in the electrostatic force, or this bond only happens after the atoms are in their cation and anion form. That is already lost or the ionic bond formed after the atoms are become ions. That is, after metal loses an electron to become cation, the non-metal gains that electron to become the anion. Okay. So the ionic bond forms. Okay. Sealing. So they close. It's the force between the already formed positive negative. So if non-metal and metal together, they they gain slash loses and becoming the bond. For the formation of ionic bond, the difference in electronegativity between the bonding partners should exceed the value of 2. Exactly. When a metal and non-metal comes together for an ionic bond, the metal ion loses one or more electrons because metals have low ionization energy, becomes a cation. The non-metal gains those electrons, have higher electron affinity, becomes an anion. These oppositely charged ions are held together by electrostatic attraction, forming the ionic bond formation. Okay, this thing I need to remember that the ionic bond should have the difference in electronegativity between the bonding partners should have a electronegativity difference of 2. Upon formation of bond, a cation is formed from the metal. Oh, it's already there. Ionic bond. Mm-hmm. So could you explain the example of Na plus, oh fuck, I forgot plus. So Na, it's like a lattice. Chlorine, it's in the gas form. Okay. So when they interact, electrons transfer from Na to forming, okay, highly exothermic reaction forming sodium chloride, an ionic compound composed of sodium ions and chloride ions. Mm-hmm. Why is it exothermic? Exothermic production of heat. Come on. Why is it exothermic? Loses an electron. Chlorine. Chlorine gains an electron, becomes ions. So the breaking of chlorine bond, is that what makes it exothermic? I guess. Enthalpy change when 1 mole of compound. Okay. Negative because lattice formation releases more energy than what is consumed in ionization. Okay, I need an explanation on Pranav 9555. Hey, what are you studying for? I'm studying for general chemistry. I failed that exam a lot of times. So yeah, I need to get my base ready. And I apologize for the latency because yeah, you're gonna hear what I said, what I replied to your question after maybe uh, 20 seconds. Are you studying for any competitive exam? No, it's just part of my university. It's not competitive exam, but I should pass this subject for continuing the laboratory subjects. So, no. And hey, Pranav, I really appreciate you for checking out the stream. Not a lot of people go through here, you know. I need explanation on this statement. Total energy change from elements. So what from what I understood, I thought CO2 breaking the bond due to gaining electron forming anion is the reason for the what energy slash heat resulting in an exothermic reaction. Not exactly breaking CO2 bond requires energy, so that step is actually endothermic. The energy is absorbed to separate into individual Cl atoms. The release of energy comes mainly from two steps: electron affinity of chlorine. Energy is released when chlorine gains electron, exothermic. That's what I said, right? And Cl2 breaking the bond due to gaining. Okay. Energy is released when chlorine gains an electron. Energy is released when. But the electrostatic attraction between Na plus Cl minus releases a large amount of energy. How? The overall formation enthalpy is negative because energy released by electron gain and lattice formation is larger than the energy absorbed in ionizing. What I meant was breaking the bond to form a stable structure. It's 30 minutes. I gotta take my push ups. Sorry, set a time for 30 minutes. simultaneously. So sodium gas, why? Formation of ionic bond requires several exothermic energy set free by negative kilojoule values, and endothermic energy must be provided. So sodium solid to sodium gas, that's endothermic, that needs energy. Sodium gas to cation sodium, that's also endothermic. Mhm. That's ionization energy. Yeah. So half of chlorine gas forms chlorine, that's exothermic. Electron plus chlorine, electron anion, it's exothermic. Up to this point, the reaction between anion would require energy, so we could talk about endothermic reaction. Overall positive kilojoule value, this would be contradictory to the observation we make when mixing chlorine gas with the sodium, as we observe emission of heat, but the consideration made so far relate to what there what but the considerations made so far relate to Na plus and Cl minus ions, which are far apart from each other, which is not the case in the NaCl formed. I don't get it. Ionic bonds. The formation of solid array or lattice involves the so-called lattice energy, leading to an overall exothermic reaction as depicted in slide 94. Ionic bond properties of ionic substance: crystalline, high melting point and boiling point. As attractive forces are stronger for ionic substance than for molecular ones, electrically conducting in melt or solution, hard and brittle. Shear stress is applied to ionic crystal. Flames of atoms slide in response to the stress. Repulsive interaction between the ions. That's the reason for being brittle. Readable. Your average Sans fan. Guess who's back? Hell yeah! Respect your average Sans fan for checking out the stream. Did I mention about one viewer Undertale? Got it. I will rewrite the okay. Ionization of sodium requires energy. Dissociation of chlorate. Dissociation of chlorine requires energy. What? Okay. Electron gain by chlorine releases energy. Your average Sans fan, how is your Undertale progress going? Or did you stop playing? It's crazy. Pretty good. I have not gotten past Undying yet. Okay. Well, the spider is hard for me compared to Undying. Okay. Are you taking the mm, what's it called? The normal path or pacifier? I remember there were three types of gameplay where you play without hurting a soul, the normal one, and the full blown purge. I'm taking the normal. I'm guessing you are also doing the normie normal. Pranav 999 So basically, you're understanding concepts from GPT. You could say that. Yeah, stuff that I did not understand, I will ask through GPT, and if GPT's again, if I felt like GPT's not telling me a right answer or it's contradicting itself, I gotta go to YouTube professors. Genocide route. Okay, that means you're gonna kill every single thing in front of you. I think that's also a cool route to take. Dissociation of chlorine molecule requires energy. Again, what if the three process here requires energy? How is it exothermic? Elect- uh, Electron gain by chlorine, that releases energy. Formation of ionic lattice, that again releases energy. The format should be readable, exam friendly. No, but step one and 2 are endothermic, so we give in energy before the reaction starts. It's the hardest route because of Undying and Sans. Yeah, if you go genocide route, you're gonna go against Sans. That's gonna be crazy. That's gonna be crazy. Exactly. Step two are endothermic, meaning energy must be supplied to remove the electron. Okay, sodium. here are the important points. A reaction doesn't happen at all like a single jump. Think of it like a sequence of events. Events. Energy input, sodium loses an electron, and chlorine molecules is split. These steps require energy. The electron attached to chlorine, and because total energy, I get it, but how does the reaction start? There's technically four routes because of true pacifists. Now what's I thought there were true, but I thought there were three. What's with the true pacifist? Get it? Like you only get to step 3 after passing through step 1 and 2, and those require energy. From what I have seen, the said reaction just happens when these come in contact, and no energy is given for the reaction to happen, but still, according to the equations, we need to give in energy. Is this some sort of case where the compounds absorb from the atmosphere or surroundings? True pacifist, you fight as real dreamer. Is that the goat lady? I mean, I did fight the goat lady, and I'm not proud of it. Yes, that's exactly the subtle point. In reality, the reaction doesn't require you to manually supply energy. The energy needed for the initial step comes from the thermal energy of the environment. You gotta say that. You gotta say that. You gotta say that. Basically, true pacifist, you have to do pacifist again and befriend everyone. That sounds like the pacifist itself, right? There's levels to the game Undertale, I gotta say. Okay, so I'm guessing that's true. I can draw a stepwise energy diagram for NA. Are you talking about any game or something? Yes, this. Yeah. It's a game called Undertale, and my friend, your average Sans is. I think he's now playing the game Undertale. Borrowed from the surroundings or the thermal motion of the atoms. Uh-huh. Okay, that kind of makes sense. Electrically conducting, crystalline, high melting point and boiling point. Could you Explain why these are the properties of ionic compounds. Because what makes it have high melting point? So it's like a lattice. This would be chlorine, this would be sodium. Okay. Ionic compounds form a 3D lattice of alternating cations and anions. Each anion is surrounded by ions of opposite charge. Yo, what's your Steam account? I might gift you something. I mean, come on, I don't think you have to do that, bro. Steam account, it's just I think it's crack it dump, I believe. But yeah. And I'm not playing games right now, so I really appreciate the offer though. I appreciate that. Your average Saints fan. To melt or boil an ionic solid, you must overcome these strong attractions, which requires a lot of energy. hmm To melt or boil an ionic solid, you must overcome these strong attractions, which requires a lot of energy. But how does external heat results in breaking this ionic bond? Do they return the shifted electron? Is that what you get? How to get it? 111814 is my code for friending. Can you do friends in Steam? I never use Steam like that. Yeah, I'm opening Steam. Let me see if it works. I do have a Steam ID. Account details. Language security. Games, screenshots, videos. Friends in chat. Got it. Oh, it's the friend code. You know what? You're a Saints fan. Top right corner. Let me try pasting that. Enter a friend's code. Oh, there we go. You're a Saints fan. YT. Hell yeah. I never thought you could send. I just send an invite. Is that how it works? I did not know Steam has these kind of friends option. That's crazy. Did you get something? So, so how does high temp results results in high temp results in what? Results in overcoming this electrostatic force that formed due to the electron shift such IFT does the heat brings back the electron to its original position. What does happen internally? I accepted it. Oh shit. Shit, we got your average sense fan. Hell yeah. Oh, I could see your whole game library stuff. Okay. That's crazy. You're playing a lot of games, bro. That's crazy. 209 hours. Damn. That's a pro right there. When you heat an ionic solid, the energy is in reversing the electron transfer. Ions remain as cations and anions. What happens internally is the heat increases the kinetic energy of the ions. Kinetic energy of the ions. Ions start vibrating more violently in the lattice. When the thermal energy becomes comparable to the electrostatic lattice energy, the ions can break free from the fixed position. In melting, the lattice is disrupted enough that the ions can move past freely each other, forming a liquid. In boiling, they escape entirely into the gas phase. Over $1,000 in Steam account. That's too much. I mean, yeah, it's if you enjoy Steam, of course. Mm, in melting, lattice is disrupted enough that the ions can move past each other, forming a liquid. So, in boiling, they escape into the gas phase. So, when they're in the gas phase, are they gonna be still in the ionic form? So, they, when, let's take the NaCl as the example. If it's at the BP, would it be in would it go to gas phase as Na gas, or Na, would they split? Let me take a At the boiling point of NaCl, it would go into gas phase as Na plus and Cl minus ion, not as neutral. Ionic compounds do not form discrete NaCl molecules in the gas. The ions remain separated because of the electrostatic lattice is completely overcome by thermal energy. So it's still in the ionic form. Oh. Mm-hmm. So when it gains energy, it's still in the ionic form. Hmm. That's. I'm missing something. I'm missing something. HCl, it releases energy. Then we give an energy, gets to the melting point. So when it what am I missing? It goes to their own specific phases. Uh, Still processing this, but I also have a doubt on the interaction between the NaCl and NaCl. How is that looking like? Your average Sans fan, Pranav 9555. I'm gonna refresh the the wait. I'm gonna refresh these chat, okay? Because this part is looking crowded. You're okay with this, right? I believe so. Inside solid NaCl structure is crystalline lattice. Here's how the interaction each Na in an octahedral arrangement. Okay, the interaction is purely electrostatic again. Uh-huh. Ah. Ah. 30 minutes? 30 minutes. Push up time. So when you think NaCl, okay, it's a really lattice holding all the electrons together. That's strong Coulombic attraction. So where, so which Na is, which Cl actually absorb the electron from the Na. In NaCl, each chlorine already gained one electron from the Na atom when the ionic bond formed. So in lattice, all Cl minus are already negatively charged and all Na plus are positively charged. There isn't a specific Cl minus that keeps the electron that from a specific Na plus in the lattice. The lattice is extended network. You know what I'm curious about, how molten NaCl looks like. There's no good image. Next is covalent bond, but salt dissociates in solution. What did I just think? I forgot. What was the thought? What's the thought? What did I think? What did I think? I forgot. Not about salt. It was something related to the channel. Damn it. Damn it. What was I thinking? Oh yeah, you got it. Just gotta send this. It's gonna help me with some stuff. Okay. Cl minus are already negatively charged, and A plus are positively charged. There's a specific Cl minus that keeps electron extended network. So the electrostatic attraction is collective. Each Na plus is attracted to all six neighboring Cl minus, not just one. Hmm. 1, 2, 3, 4, 5, 6. Okay. Uh-huh. How is the conductivity of these compounds, like ionic? Also, why is there a specific reason for being called a salt? Why? What happened, GPT? Come on, stop playing with me. Covalent bond. Nonmetals do not like to donate electrons, so the way to achieve noble gas configuration is via sharing of electron pairs. It's commonly written as the conductivity of the ionic compounds depend on whether the ions are free to move. Ions are free to move. Okay. Solid state ions are fixed in the crystal lattice. They cannot move freely, so ionic compounds do not conduct electricity. Molten state or dissolved in water. Lattice is broken, melting or dissolving. Ions are free to move. Ionic compounds conduct electricity well in this state because the cations and anions can carry charge. Can carry charge. Okay, okay. Lattice is broken. Ionic compounds conduct electricity well in this state because the cations and anions can carry charge. Poor conductor. As nobody pray for me. How long does my arm goes? Okay. In chemistry, a solid generally refers to the compound formed from neutralization of an acid and a base. Ionic compounds in aqueous solution are often called salts because they dissociate into cations and anions. Example: NaCl is called a salt because it can be formed from HCO and NaOH. So it can be formed from NaOH and HCl. Oh shit, okay. Okay. So Na and Cl2, that is an exothermic reaction. So in a solution, essentially salt is traditional chemical term for ionic compounds. So in the case of Na plus Cl2 is an exothermic reaction. Is that the same case for what? HCl with this is commonly written as covalent bonding cannot occur between same atoms showing identical electronegativity, but also between different atoms such as okay. So but showing identical electronegativity but also between different atoms. But these different atoms, they're all nonmetals. I'm guessing covalent bond occur for elements having high electronegativity. No. Mm-hmm. Distorted ionic bond, polarized covalent bond, covalent bond. Not exactly the same, but related in terms of energy changes. Na plus Cl2 gives NaCO. This is a direct combination reaction. Sodium metal reacts with chlorine gas to form NaCO. Sodium metal reacts with chlorine gas to form NaCO. Energy is released mainly because the lattice formation of NaCl releases much more energy than energy required to ionize. More energy formation of NaCl releases more energy than the energy required to ionize Na and dissociate Cl2 minus. Okay, that's why it's called exothermic. This is acid-base neutralization reaction. Energy is also released, but here the driving force is formation of strong OH bond in water rather than lattice energy. Mm-hmm. The OH and H, those are what drives this reaction. Uh-huh. So both reactions are exothermic, but the mechanism of energy releases differs. Energy released due to the formation of ionic lattice. The final product in both cases is NaCl, but the root and energy contributions are different. Okay. Mm-hmm. How are the enthalpy of formation? How are the enthalpy of formation for Na Cl Covalent bond dipole momentum. Lewis structure formulas. I'm still not halfway. Lewis structure. I gotta learn this. Derivation from octet rule. Resonance structure. Yeah. Covalent bonding orbital overlap. These were the parts I fumbled so bad. Mhm. Molecular orbitals. Yeah, this part I fumbled here. Covalent bonding, multiple bonds, polar, non-polar. Metallic bond, there we go. The sea of electrons. Okay. Okay. It's still doable. Don't get scared. It's still doable. Here's a summary of standard endothelio formation for the species you asked for. Oh yeah, these are like, okay. Standard state, yeah. Minus 92, minus 425. So, which, so formation of which produce more. I'm guessing the Na with Cl2 as they are in their standard form. Exactly, comparing the two, this is direct formation from the elements in the standard state. So, okay, releases a large amount of energy because the lattice form from neutral atoms and strong ionic interactions are established. This is a neutralization reaction. Energy released from conclusion formation of releases far more energy because it is full lattice energy. Mm-hmm. Na So in their they produce more energy when they're in the standard state. Okay, but to get these acids and bases, NaOH. O is electron hungry, and uh, Cl, HCl. Chlorine absorbs electron from the hydrogen. Okay, so that they exist in that form. Hmm. Hmm. Could you explain on the NaOH and HCl? I know that the Na donates electron to the O part of the reaction, while the uh, CO form, not form, from. Mm-hmm. Explain formation of these acid and base. GPT, why are you doing this? Gesundheit. I'm asking about the formation of the NaOH and HCl. 20 euros. Cyberpunk 20 euros? What the fuck? Truck Simulator 5 euros. Whoa, what the fuck? Did you guys see the offers? Silk Song, that's good. That's a good offer. That island, I thought it was so cool. Detroit. Oh, no fucking way. 4 euros. No. I'm in the brokest stage of my life, so I cannot buy it. Valhalla. 2017. Okay. That looks like a good game. I'm back here. People Playground is 90% off right now. What's the People Playground? You could search up the game. Where's the search? Oh, what the fuck? It's 81 cents? Oh, it's like a simulator. Ah. I used to watch a lot of shit like these back in the day. And it's only Windows. No, it's only Windows. And god damn it, I don't have a Windows machine. Right. Equations again. I don't it's not in a readable form. Elder Scrolls. Hitman Absolution. That's a cool game. Forza, I do have Forza, but Escape the backrooms. Little Nightmares. Geometry Dash. That's a cool game. Yeah, it's a difficult game. That's it. It's not Souls-like. Silk Song. Dude, I really want to play this game. Let me get my money up. I need to find a job first. After that, yes. Chronos. Monster Hunter. That's 10 euros. That's cool. Cuphead. 13. Tsushima. Uh, Far Cry. Oh. The Isle. When this when did this release? 2015. Oh, it's an old game. Subnautica. A lot of games. From elements in their standard states. Half of hydrogen gas plus half of chlorine gives HCl and alpha formation. About 92.3. Exothermic because forming HCl bond releases more energy. Uh-huh. Formation of NaOH. Exothermic due to the formation of... Oh, shit. Half of oxygen plus... Which releases more energy than required to break the... What? Exothermic due to the formation of NaO ionic bond and OH covalent bond. NaO ionic... Okay. Which releases more energy than is required to break... Okay. Is lesser strength is lesser, oh come on, lesser compared to the NaCl bond. I guess. Yes. That should be the answer. If the universe is right, this should be the answer. Okay. Yes, that's correct. Charge and size factor, okay. Ionic versus mixed bonding. Highly symmetric cubic lattice, okay. Well, I'm not gonna lie, I'm really hungry right now. I gotta eat something, people. Or else this brain is gonna blow up. So, YouTube, I'm gonna end the stream. Your average Sans fan, appreciate for checking out the stream. The Pranav 9555, appreciate you for checking out the stream. We will be back after eating food. Peace. Say what you want.